Well, next topic I'd like to talk about is NFPA 72 primary power requirements for the fire alarm system 10.6.5. And how important is primary power for the fire alarm, guys?
You have to have it, don't you?
Yeah, pretty much. Hello, everyone, and welcome again to the Temporal 3 podcast, where we talk about fire alarm. I'd like to introduce my co-host today, Mr. Ed Heyden. Welcome, Ed. Thanks for joining us.
Thanks for having me.
And as always, Mr. Charles Aulner. Thanks,
Hello.
Charles, for joining us today.
Absolutely. Let's hit it.
Let's hit it.
To it.
So the first thing I'd like to talk about today is, from the NICET perspective, the importance of having the correct code additions in the exam. Charles, how important is that?
It's critical, but I think you overlooked one key aspect. And I've seen this, I'm sure you probably have too, walking into a NICET test, individuals who have no code books whatsoever. So walking into the test, you have to have code books, and the correct addition is really important. Ed, what have you found?
So what you're saying, Charles, I'm kind of thinking on the same line as you are. I've always thought and found that one word in the code makes a real big difference on the outcome of how that it's going to be answered. But you agree?
Yes.
And based upon different code changes and how they work with every 3-year cycle that they go through, one word that may have been in there in the code that you're possibly using is not what they're requiring on your NICET exam for you to answer that question correctly. So I agree with you.
I can think of one in particular that happened a couple cycles ago, but where the NFPA 72 went from 20% derating factor or safety margin, they keep changing the term, to 25%. And if you're working particularly at a higher level exam and doing a battery calc and you're using a code that says 20%, and NICET's currently testing on 2022 of 72, which requires 25%, that's a huge opportunity to make a mistake. And especially on a question that really should be a pretty easy question to answer, simple math.
It absolutely does, Brian. I got to agree with you on that. And what happens is a lot of times when you go into the NICET exam, the guys take their field experience in, and what they're doing in the field may not necessarily be doing what we're saying in the code that's required to be used for the NICET exam. So, here still in my jurisdiction where I work, we're still using the 20%. But if I were to take a NICET exam, what would my correct answer be? 25%.
Right. And Charles, Ed brings up an excellent point about real world versus code world. And, it's all about the addition. And that's why I wanted to start out talking about the correct code addition, how important that is.
Hey, the AHJ isn't going to grade your NICET test.
Excellent point.
NICET's not going to go out and inspect your job either,
That's
are they?
true. That's true.
Yeah, exactly. Really, really important differentiation to make, guys. Real world versus NICET world. And when we're taking the NICET exam, we're in NICET's world. We're playing by their rules. And what you all do in the real world may be completely different. It's really important to make that differentiation.
Agreed.
Well, next topic I'd like to talk about is NFPA 72 primary power requirements for the fire alarm system 10.6.5. And how important is primary power for the fire alarm, guys?
You have to have it, don't you?
Yeah, pretty much.
I mean, if you want your system to run, that's one of the powers that's the requirement for that system to run. That and the secondary power. But primary power, I can go on forever with that subject matter.
Yep. And primary power requirements, a couple things that people need to remember, that the people on the install and design side need to remember is, first of all, dedicated breaker. Have you all seen the installs where it wasn't a dedicated breaker?
I can give you an example.
Sure.
I actually did an inspection last week where the guy had a circuit coming out. It was going to his garage door opener, and then to an outlet directly above the panel, and then into a panel.
Wow.
So obviously not a dedicated breaker for sure. It was servicing two other things, an outlet and a garage door opener in his building.
At least it wasn't on a switched outlet.
It wouldn't have surprised me if there might have been a switch somewhere in line there either, Chuck.
Yep. One that I've seen that I will get questions about, and I'll state my opinion on this, is where the installation company will put an outlet below the panel for the convenience of the individual who's using the laptop to program or service the panel. And they put put an outlet below it, say, okay, great, the guy can plug in his laptop there. And the issue that I have with that, and why I think it's not appropriate according to code, is that outlet, unless it is protected, now is accessible to anybody. They want to plug a Coke machine into it or a shop vac or whatever into it. It's no longer a dedicated outlet or dedicated circuit for the fire alarm. And somebody puts a high load thing on there, they could be tripping the breaker and basically taking out primary to the panel.
Well, absolutely very true. And, any seasoned technician would know that if they're actually programming a panel directly and you plug it into an outlet, normally what's going to happen, you're going to get a ground fault on that immediately.
Absolutely.
So, normally, I would avoid doing that. But, Bryan and Chuck, I'll tell you, the things that I've seen out in the field over the last 35 years, it wouldn't surprise me if they just didn't come directly from the main breaker and go directly into the panel. Sometimes the way things happen with no complete disconnect whatsoever. What does happen sometimes is they do have a side arm switch that acts as that disconnect to that, or that breaker to that. You'll see that a lot on a lot of legacy systems out in the field.
Wow.
Yeah.
Interesting. Charles, what have you seen from your side on that aspect?
Well, one thing about the outlet, what if they put the outlet inside the panel? Do you think that would be a better solution?
Definitely a better solution. I don't know about code compliance. I guess if it's in a box and protected by conduit, Ed's shaking his head no.
No, that wouldn't work. Yeah. Yeah, I think you'd have an issue with the AHJ, the inspecting AHJ, with that outlet inside that fire panel. First of all, you got to ask yourself: is that panel suitable and acceptable to be holding 120 volt outlet inside of
Good
it?
point. Good point.
I doubt you'll find a lot of room inside that panel once you put the battery, secondary power in order to do that. I'm not saying that it couldn't happen. I'm
Right.
saying that,
Well,
I don't take anything for granted, honestly.
And the other aspect is, how tough would it be to actually put an outlet in that's not on the fire alarm circuit?
Oh, very true.
It wouldn't be hard at all, would
Not
it?
at all.
So
Not
having an
that's
outlet
true.
below the panel or in the vicinity of the panel would certainly be okay, as long as it's not on that dedicated circuit.
That's
Right.
exactly
Yeah.
right.
Exactly. Exactly.
Agreed.
Another consideration for primary power is the location of the circuit disconnecting means, the breaker, for primary power. And the code actually is specific on this about identification, that it needs to be identified in the panel, needs to be identified on the documentation for the fire alarm system, and it needs to be identified at the circuit disconnecting means itself. So you get three places. We know in the real world, sometimes that's a big mystery. Where's the panel? Which breaker is it? How do we find it, Ed? We short primary power and listen for the click, right?
It's the only way. Make the sparks fly.
Make the sparks fly.
It's very true. You say a lot of people are just at the end of the job, when it's all wrapped up and done. The one thing that I see neglected is actually the documentation that should actually be followed through. So the location of that primary power circuit breaker or means of disconnect should actually, of course, be listed inside the panel for anyone going in there to service it, and also to do whatever they need to do. The authority having jurisdiction, I think, needs to play a key role in something like that when the final job, the end of the job, when the certificate of occupancy is granted, or the building is actually going to be occupied.
So,
Absolutely.
Ed, you're saying that the job isn't complete until the paperwork's done. Is that true?
You read between the lines there, didn't you? You're absolutely correct. Yeah, that's part of it, man. And we all love that paperwork at the end, don't we?
Was our fellow instructor Doug Mosley used to tell a story about that and said, yeah, try doing a job and not completing the paperwork afterwards and see how you feel, type of thing. I won't go into that anyway.
Oh, I know what you're saying. I do remember that story.
Yeah, there's certain things that require paperwork.
Absolutely.
Well, last thing I'd like to talk about in this edition is questions from the field. And we had a question about a question on our practice material for level 3, in fire alarm systems. And the question is from our red book, and the student asked the question. The question is as follows: during plans review, there is a concern about spacing of spot type heat detectors in an area. The ceiling is smooth and level with a height of 30 feet, and the heat detectors have a listed spacing of 30 feet. What is the minimum spacing of heat detectors in this application, with options of 10.2, 11.5, 11 11 and 11.5, and then 12 feet? And the student was questioning why the spacing, because it was a 30-foot ceiling. If we look at the table 176351, 28 to 30 feet, we multiply the listed spacing times 0.34, gives them 10.2, but that is not the correct answer to the question. Guys, where do you think the student went wrong with this?
You have to read the whole table, including the notes at the bottom.
Yep. Nobody likes to read down.
You mean to tell me there's another place you need to go to get the correct answer for that?
Absolutely.
Pray tell.
And first of all, this table sucks.
Yes, I agree.
Well, how long have we seen this table, though, Charles?
I know.
How many years?
It's been in the code.
How many editions?
Oh, gosh. Since 93 at least, probably before
my
that.
exact thoughts, right.
Probably longer. And you're right. I mean, going back to the table itself, one of the questions that we get as instructors all the time is, okay, if you have an even numbered ceiling height, well, 10 foot, 12 foot, 14 appears in the table twice. Which one do I use?
Well,
if you read the table a little bit closer, ceiling height greater than and up to and including. Is that a common mistake we see from students in classes?
A lot. And normally what happens is you need to go and show them on hand exactly how it works. I mean, and then after you give examples, not only examples possibly that we're showing on our presentation, but something that you would just throw out. So let's say I have a ceiling that's 16 feet, or I have a ceiling that's 14 and a half feet, or a 12-foot ceiling, or a 20 and a half foot ceiling. Let them go and take a look at that. But the point that you're trying to make here, Bryan, is if the person actually did the math based upon the 30 and 30, the 30-foot spacing and the 30-foot ceiling, they would come up with an answer of 10.2, which is the wrong answer. They need to go to 176353 in order to look at that, because there's something in the code that actually tells you about required to be less than a certain amount times the height of the ceiling. How many people miss that?
A huge amount.
Me.
Right here. Me too. Me too.
It's a very common mistake. And again, I always tell our students it's better to make a mistake in our training than to make the mistake in the NICET exam. And this is a level 3 question. And this is the kind of thing that NICET, at level 3, NICET is all about the fine details. That's why level 3 has the highest failure rate of all the NICET exams, because the fine details where people are gotten. And you're absolutely right, Ed. 176353 says spacing of heat detectors shall not be required to be less than 0.4 times the height of the ceiling, not the spacing of the detector, height of the ceiling. Just coincidentally, we have 30-foot spacing on a heat detector and 30-foot ceiling. But if we apply that, the minimum is 30 feet spacing height of the ceiling, times 0.4. The minimum spacing required is 12 feet, not 10.2. And okay, it's a little less than 2 feet difference, but in a large area, could it make a big difference in the number of detectors?
Absolutely. And based upon the way that smoke could possibly, heat could travel across the ceiling surface, absolutely. You bet.
Absolutely. The other thing about this too, and why this requirement in there, is to prevent basically, let's use the word ridiculous spacing reductions. This is our example question is 30 foot. Imagine that applied to a 15-foot listed spacing detector, like a 190 fixed temp, which is typically going to be 15. You could be down around 7 or 8 feet. And, big difference between 7 or 8 foot spacing versus 12-foot spacing. So the code does, for once, actually take into consideration things that are excessive and says you don't have to go below this. So that's something very important to remember when we're talking about minimum spacing. It's something to keep in mind, particularly at higher levels of NICET.
Bryan, are you implying the code makes sense?
Sometimes, yes.
I don't even know who you are anymore.
Oh my God.
Sometimes it
Charles?
does. I have to say that sometimes the code makes sense. Not all the time. Many times it doesn't. Many times it's extremely frustrating. But
Yeah.
in this instance, I got to say that the engineers at NFPA looked at this and said, you know, sometimes we're getting a little excessive. Here's how we prevent being too excessive.
And the people that write the test questions for NICET know that you may not look at this in order to get that correct answer.
Absolutely. Absolutely. Again, that's why level 3 fire alarm has the highest failure rate of all the NICET exams. That's
Very
not just me
interesting.
talking. That's Chip Hollis at NICET said the same
Very
thing.
interesting. Hmm.
Right.
And our students say the same
And
thing.
our students. Yep. Absolutely. Yeah. So across the board, we have validation on this. All right. Well, guys, I want to thank you again for joining us in the podcast today. As always, good to see you, good to talk with you and talk fire alarm. That will
Likewise.
conclude this edition of the Temporal 3 podcast.
Bye, everyone.
Take care.